Okay, now let's discuss about the pooling layers. Even I already touched a little bit on pooling layer in the previous lecture before we go into this slide. Actually, that is the idea about this pooling layer. If you remember that, again, let me review on the previous slide there. Okay. Again, let me remind you on this slide again, which is this one. Okay, so again, instead of convolutional layer, we have a pooling layer. Okay, which is the third item over here. Okay, so a pooling layer is one of the if you go back to the our example CNN architectures, which is in this slide. This one. So pooling layer is the one that happen at this subsamplings. Again, I already discussed with you is that in subsampling section over here, doesn't matter is it over here or over here, then that is where the pooling layer involved. But in general, subsampling can be done in two ways. One is by using a pooling layer, another one is by using dropout layers. But in our syllabus, we don't cover the dropout layer because pooling layer is enough for you to create the CNN architectures, because I think most of time, if you are try to design CNN architecture, if you want to establish one architectures, then people will use either using one of it, meaning that if they are designed the subsampling using a pooling layer, they will not use a dropout layers. And if they are using dropout layers, and then for that architecture, they will not using a pooling layer. So that's why that's why in these pictures it just show you a subsampling, because in my opinion, subsampling is represent both. It doesn't matter is it a pooling layer or dropout layers, but in our syllabus we just cover a pooling layers. Okay, again, pooling layer is the purpose. Again, I always remind you that pooling layer is roughly speaking, is the purpose of that layer is to shrink the matrix or shrink the size, because that is the one that will make, because that is our objective, because from the left hand side to the right hand side of the architecture, it start with a bigger size matrix, and then it shrink into a small size, and lastly it will become one single matrix element, which is represent the level of the image or the decision or in the interpretation of the input. So that's why we need to shrink that. Okay, so that is what is the main purpose of pooling layer. But if you read through many other deep learning's book, okay, they will also mention that actually the subsampling doesn't matter is it a dropout or pooling layers. The purpose, the other purpose for why we need to shrink that, okay, is because we want to avoid overfitting. Okay, if you remember what is we always talk about overfitting before. Okay, we start at the I think if we start at the first chapter. At the beginning of this course, we always discuss about the overfitting, and I also discuss about overfitting many times. Okay, I think from starting from the introduction of deep learning, also we already discussed about the overfitting, how actually we can avoid overfitting. One is of course you cannot have hidden layers, hidden neuron too many, is because if you have a hidden neuron too many as compared to the input dimension, then overfitting will happen, because that represent the more hidden neurons, number of hidden neurons, then you will create a the increasing the complexity of the function. Okay, that is a same terminologies to linear regression or logistic regression that you learned before. If you increase the order of the function, then the complexity will increase. But let's say your input dimensionality is just a small size, it will also make the overfitting happen. So that's why you, in order to avoid overfitting, one way is you need to make the function less order or less complexity. That is one way. Second way is, of course, when you learn how to use the MATLAB function with NN tools, you already realize that they come out with some sort of stopping criteria where they try to check the validation loss, okay, during the training. Okay, that is another way to avoid overfitting. Okay, and this is in CNN, this is another way to avoid overfitting, which is by introducing with the pooling methods, because by subsampling or shrink the matrix, actually you will also reduce the complexity of the function, and by reducing the complexity of the function, then you might reduce or avoid the overfitting. So that's why one of the purpose of pooling is we can avoid overfitting. Okay, so you need to remember that there's a many way to avoid overfitting. Okay, doesn't matter which type of machine learning, they have their own way to avoid overfitting. That's why you will see that overfitting can be happened, but there's a many way people try to propose or to suggest in order to avoid overfitting. Okay, there's a many way. That you also realize that during the beginning of this AI course, there's a during the linear regression, there's a there's a way to avoid overfitting, and then in this CNN, you see that one way to avoid overfitting is by introducing with the pooling layers, okay, or subsampling process. So that's why we need to do the subsampling. Even I said, when I discussed in a previous lecture, I talk about the purpose of subsampling is to reduce the matrix size. Yes, that is one. That is the one objective of subsampling or pooling layer, because the nature of CNN, you need to have because at the input side you have a lot. You have a big size of metric, then you need to shrink, and at the end you only left one matrix element that represent the decision or the final output that label the image, that represent the label of the image. So that is the purpose of pooling layer. And another additional purpose of pooling layer is to avoid overfitting. Okay, because if you don't have a pooling layer, then you cannot reduce the complexity of the function. Okay, so in general, pooling can be divided into two approach. Okay, one is the maximum pooling, and another one is average pooling. Okay, before I discuss further about the pooling layers, let me go back into this item, because I also discussed this in the previous lecture, that about the stride and padding. Okay, I mentioned in the previous lecture, padding and stride is something which is not always happen at convolution. Okay, because when I discuss about stride and padding, previously we relate this element with the convolutional operation. Okay, but I also mentioned to you, instead of stride and padding is designed for convolution layer, in it also has been used. It's also is I'm sorry, it's also used in pooling layer as well. Okay, so that's why I remind you in the previous lecture that if you remember, I mentioned that stride and padding is the operation which is not only happen at the convolutional layer, it also happen at the pooling operation. But in pooling operation later, you will see that stride is always happen. It can be based on my experience seeing the people design the CNN architecture. I see that stride have been implement in most of the time stride have been used with pooling operation, but it's very rare to see padding attached with pooling operation. Okay, so that's why I based on my experience, I still don't find people include padding in pooling operation, but I see people include stride with pooling operation. But it's not similar to convolutional layer, because in convolutional layer you will I see many people try to attach their convolutional layer with stride and padding as well. Okay, but pooling is very rare to see people attach with padding, or it's very rare to see people doing padding during the pooling operation. But stride, yes, we can see people always attach with the pooling operation. Okay, so now let's go back to the discussion of the pooling layer. Yep, so again it's divided into two. One is the maximum pooling, another one is average pooling. Okay, so I think for those who learned image processing, this one is almost, I can say, almost similar with non-linear filter. Okay, if you remember, in non-linear filter we have a median filter. Okay, median filter, and then we have maximum filter, and we have minimum filter. This maximum pooling is close to max filter. Okay, but for those who don't learn image processing, don't worry, just maximum is very common sense. Okay, you can see this is, let's say this is your activation map. Let's say this is your input. Again, I just remind you, I call it as an input matrix, because it when I say input matrix, it can be input image. If this is at the beginning of your CNN, but this one is in the middles of your CNN architecture, then it can also be your activation map or feature map of previous layer. Okay, the output of the previous layer. So we call it as activation map or feature maps. So if you're applying the maximum pooling to this one, okay, if you realize that in this example, okay, the window size of the maximum pooling is 2 times 2. Okay, that's why you can see that they are have a window size of 2 times 2, and then which value that overlap in this window, you need to consider, you need to observe and find which one is the maximum value. So it should be this one, right? So that's why at the output side you just copy this 20 into this side. Then another thing is that you realize in this example, when they slide the window to this yellow region, actually they jump 2 steps ahead. 1, 2. Okay, so This example is actually a pooling operation. Okay, pooling operation where is the filter size is 2 times 2 and the stride equal to 2. Okay, so that's why I said stride is also can be attached with the pooling operation. It's not just convolutional layer. Okay, so this is one of the example. Again, it's very rare to see people are using padding in pooling operation, but stride I see most of the time people use it. Okay, this is one of the example. You can see that no pooling and no padding, but we have stride. And then on this side, which value is maximum, which is 30. So that's why you go into this side. So the size that is shrinking is because of the stride is equal to 2. That's why when the stride is equal to 2, it shrink the size as well. And then with this one, which one is the maximum value? 112. So going into that side. And this one, which one is the maximum? 37. Okay, so you're going into that side. So you can also compute that by using this one, which is called as averaging pulley. So for averaging, you just average the set of matrix element that overlap that window. Okay, for example, this 13 is the average of this set of matrix element. So that's why you get 13, you get 8, 79 and 20. Okay, so again, if you talk about the architecture in term of network, what happened is actually in subsampling operation, which is in this case in your syllabus we talk about a pooling layer. So again, let's say you have let me draw something seem to be like your neurons. Okay, assume this is convolution. Okay, of course this is convolution. As you can see that we are not fully connected each and every previous neuron with this adjacent neuron. So you can see that this is output of convolution between these 3 neuron. This one is output of convolution between these 3 neuron, and this one is a output after you do convolution between these 3 neuron. So this is actually this is the convolutional layer. Okay, so let's say you want to apply the subsampling here at this stage. So let's say this is the neuron represent the output after applying the maximum pooling. Okay, let's say among these 3 output, the maximum value is this one. Okay, after applying a pooling layer. So you will see that the one that passed to this stage is only this one, while this one there's a no connection here. Okay, you just there's a no connection because you cut this network, you cut this network. So as you can see in the neuron architectures here, okay, the architecture of CNN in form of neuron over here, by applying the maximum pooling layer or pooling layer, actually you also, if you look into this form, it's look like you are disconnect many network. So that is how actually you are reducing the complexity of the function, because once you pass from here to here, you only pass this one will be blocked because of the maximum pooling operation or pooling operation at this at this stage. Okay, this one we have a pooling layer. So that is where you are reducing, you keep reducing, and you make the CNN architecture more and more simplified. Okay, that is okay, again, that like I discussed before, CNN itself, why you are replacing CNN, um, you are using a CNN instead of metric multiplication, because by having a convolutional operation here, you have reduced the connection. Okay, you can see that it's not a fully connected. Then with additional or integrate with maximum pooling, you again more and more reducing the connection. So that's why now the deep learning architectures that you design by using CNN produce a more and more simple network as compared to deep neural network. So that's why this approach is better than using deep neural network, where the deep neural network is only depend on fully connected layer or metric multiplication operation. Okay, this just showing you how actually pooling happen there in a form of neuron there, in neuron which is represented by a circle that represent the neurons there. Okay, this is some example how actually the poolings make the representation of S smaller and more manageable. So operates over each activation map independently. So again, is a is a subsampling, or another word for subsampling is still downsampling. You are reducing the size. Okay, for example, this is activation map of the previous operation. Let's say this is the output of the previous convolutional layer, and then by applying here with pooling layer, then you reduce the size. Okay, why we choose the maximum, of course, or average is, of course, maximum value is like which one is firing the best signal that firing. Okay, if you related to the network ANN, then okay, if you imagine that activation function, the purpose of activation function, you want to it work as a filter, meaning that if you find out that the signal is not have a low strength, you are not firing. If you have a input signal which have a high strength, then you are firing. So maximum filter works like that, meaning that during the convolution you are firing it by producing the O matrix, and again you have another filter at the pooling layer, which is, that's why you are using a maximum pooling, because you only choose the maximum value that are firing to be passed at the other side, because you believe that the one which have the high strength will have a good features as compared to the others feature which is not so important. So that's why they come up this maximum pooling. Okay, so that is one of the idea behind it. Okay, if you want to know why they introduce with the maximum operation and so on. Okay, but I think for averaging, that is another thing. This another way around, meaning that maybe they don't want to leave out any things, because every part of it is firing. So that's why they go for average value. Okay, that is I think the concept of why they introduce with the average pooling, and why they introduce to you with maximum pooling. That's the reason behind it. Okay, this is another example. Okay, let's say this is your activation function, activation maps of the previous come from the which is the output from the previous layer. And then if you're applying a maximum pooling with the filter size 2 times 2 with the stride equal to 2, then this is what you get. Okay, again, because the stride is equal to 2, then you jump. This is the first operation, and then you jump 2 steps ahead. So that's why you go, the second operation is at this region. So that's why among this point, which one is the maximum? So of course it should be 6 going into that points as the output. And among this value, which one is the maximum? Of course it should be 8. so you have going into that as the output. Okay, you can repeat that until you finish, so it will produce 2 times 2 output matrix. Okay, this is just you can read by yourself. This is just a summarization how to know whether your how to find the volume or the size of the output matrix based on the window size. Okay, again, this is the this is the window size, and then you have the H there. And also the depth there. So this is the depth. This is the depth of the input matrix. This is the width of your input matrix. This is the height. This is so it is mean this is might be your X. This is your Y. This is your Z dimension. And then this is the filter. And then how much the stride. Then you can estimate what is the output of your output matrix dimension if you apply the pooling layer. Doesn't matter is it average pooling operation or maximum pooling operation. Okay, this is just I show you some animation. Again, this is maximum pooling operation with 2 times 2 filter, and the stride size is the stride is equal to 2. So again, I will not touch on the backpropagation. Again, backpropagation of CNN is similar to what we have learned before in ANN, because we already do a lot of derivation in order to prove that how actually the backpropagation works. Actually, the concept is similar for CNN, but because CNN is too big, so it's very hard to to do the hand calculation to derive on that, because the size is very big. So but because you already derive with a simple ANN, that is actually represent the CNN as well. So again, just skip this slide. So because the local gradient here is what is meaning by the local gradient here is your what? This actually is your delta. So okay, it's your delta. This is also your delta. Okay, this is represent your delta actually. So that is the meaning by local gradient. Okay, I will not touch on that. Okay, this is actually the animation or how actually the deep learnings work. But if can you realize that this is not is it a CNN? Is it a CNN? For this example, is it a CNN? Okay, this is the just showing you how actually they do a backpropagation or training the deep neural the deep learning the deep learnings there. But the question is it a CNN? Actually, this is not CNN. Okay, don't get confused, because I don't because I find out this picture or this animation is very interactive, so that's why I put it here. Actually, the title should the title here not represent this image is not represent the title. Okay, this is actually deep neural network. Why I call it a deep neural network? Because you have more than one hidden layer, and then actually each neuron over here in hidden layer is fully connected with the previous one. So that's mean over here you have a matrix multiplication operation. This one part also you have a matrix multiplication, and this one also you have a matrix multiplication, or in other words, this one is a fully connected layer, this is a fully connected layer, this one as well is a fully connected layer. So if every point over here use a fully connected layer, then it become a deep neural network. It's not a CNN. But just show you the animation is actually what happened in training. Okay, you have fast forward, you have I'm sorry, you have a forward pass, you have backward pass. Okay, then you update your W. Again, you go to backward, forward pass and backward pass, and so on. Okay, this is the, I think this is a minis data set. Okay, you have an image of handwritten numbers there. Then the ANN here, or DNN here, try to estimate what is the number that you return in this image. The input here is this one, the output is this one. So after during some training, then you use it for testing. This is the mechanism of testing. Don't worry, because later I will show you the same example, meaning that we will using this kind of data set, but we implement it using CNN, and you will see that the output, or the performance of the system is still excellent. I think in more than 90% the accuracy. Okay, but we will use the same data set, but we will implement it using CNN that we build from scratch.